Welcome to the southern tip of Texas, where the coastal wind blows across wild marshlands near the Gulf of Mexico waters. Here stands an industrial complex that looks unlike any other factory that has ever existed in the history of aerospace engineering. There are no high secretive walls here, nor are there neat assembly lines like those found in the modern automotive industry. This place is called Starbase, an open-air factory, part experiment and part construction site, where everything is exposed to the elements. SpaceX is attempting to do something here that humanity has never successfully achieved in the history of space exploration and flight. They are building a ship large enough to transport humans off planet Earth in mass numbers, changing our destiny forever. That ship is named Starship, a vessel designed to rewrite the rules of physics and economics in space travel permanently. For over half a century, the aerospace industry believed in one absolute truth regarding materials used for building space-bound rockets. They believed that the lighter, more expensive, and more high-tech the material was, the better it was for reaching orbit. Titanium, carbon composites, and special alloys were the standard. But Starship completely rejects these expensive norms in favor of something else. SpaceX chose stainless steel, a material that is cheap, heavier than aluminum, and easy to work with in any environment. It seemed completely unsuitable for rockets, a choice that made the entire aerospace industry gasp in shock and total disbelief. But here at Starbase, stainless steel is not a step backward. It is the foundation for a massive production revolution. Starship does not just fly in the atmosphere. It must withstand thousands of degrees when returning to Earth from orbit. It must also endure temperatures near -200 degrees Celsius when filled with cryogenic liquid methane and liquid oxygen. Stainless steel has a unique advantage known as cryogenic hardening. The colder it gets, the stronger the material actually becomes. This property makes it ideal for the hull, the fuel tanks, and the main load-bearing structures of the massive vehicle. At Starbase, giant rolls of steel are brought into the factory, ready to be transformed into something capable of flight. They are cut, bent, and turned into hull rings that stand taller than a human, forming the rocket's skeleton. In traditional space industry, every weld takes place in a strictly controlled environment to ensure absolute perfection and cleanliness. But at Starbase, you can see steel rings with a diameter of 9 meters being welded right out in the open. Automated welding robots move around the hull, creating vertical and horizontal seams that stretch for dozens of meters in length. This is not carelessness. This is heavy industrial thinking, where speed and repetition are prioritized over cosmetic perfection or aesthetics. Speed is important. Repetition is important. Every error is viewed as valuable data to improve the next version of the ship. Starship is not a perfect product from the start. It is an evolving prototype that gets better with every iteration. When the steel rings are finished, they are stacked on top of each other using massive cranes in the high bay. Ring by ring, Starship begins to rise from the ground, resembling a skyscraper under construction rather than a delicate rocket. Unlike the Falcon 9, which is assembled in a closed factory, Starship is built like a building rising up. Each completed hull stands over 50 meters tall, not counting the booster, with a diameter of 9 meters across. It is larger than any space vehicle ever built. This is no longer just a rocket. It is a flying structure. Inside Starship are massive fuel tanks designed to hold liquid oxygen and liquid methane, occupying nearly the entire volume. These tanks occupy almost the entire volume of the ship and must withstand extreme pressure without leaking a single drop. Every weld in the fuel tank is checked by ultrasound, pressure tested, and subjected to sudden freezing to ensure integrity. Just a small crack could destroy the entire ship in a few milliseconds, so perfection in these welds is mandatory. Starship does not use parachutes. It does not use wings like an airplane. It relies on a unique re-entry profile. When returning to Earth, It falls in a controlled manner, using large steel flaps to adjust its posture in the atmosphere. These flaps must withstand terrible heat, operate with precision, and must not jam even once during the critical descent. They are installed directly onto the hull, reinforced by an internal load-bearing structure to survive the intense forces of re-entry. At Starbase, the explosion of a Starship is not considered a failure. It is simply part of the learning process. Each explosion provides data, exposes weaknesses, and leads to a better next version. Failure is an option here. There is no perfect model on paper. Starship learns by reality. This philosophy drives the rapid pace of development. Prototypes are built quickly, tested early, and improved continuously. The cycle of build, fly, and iterate never stops here. Starbase resembles a giant outdoor laboratory rather than a traditional factory. It is a place of constant, visible experimentation. Starship was not designed to just send a few people to orbit or to launch a small communication satellite. It is designed to carry hundreds of tons of cargo and dozens of humans to the Moon, Mars, and beyond. To do that, the ship must be big. Not for show, but to reduce the cost per kilogram of cargo. Looking from afar, Starbase seems chaotic. But within that chaos is a different kind of order, driven by ambition. It is the order of testing, the order of speed, and the order of rapid technical evolution and engineering prowess. Here, people are not trying to create a perfect ship. They are trying to create a system to mass-produce spacecraft. They want to build spaceships the way we build airplanes, making space travel accessible and routine for the future. Starship is not yet complete. Starbase is still changing every month. The landscape of the future is being built now. But one thing is certain. For the first time in history, humans are building massive spaceships right here on Earth. The goal is not just a single flight, but a multi-planetary civilization that spans across the stars and generations. And it all starts from these stainless steel welds crafted under the windy, sandy skies of the South Texas coast. Let's look closer at the welding process. It is the literal glue that holds this massive dream together against gravity. While manual welding is used for touch-ups, the main structural seams rely on the consistency of advanced robotic automation. These robots work tirelessly, day and night, ensuring that every millimeter of the hull is fused with maximum strength. Quality control is rigorous. X-ray technology allows engineers to see inside the metal, ensuring no hidden flaws exist. The steel is tough, it bends, it stretches, but it refuses to shatter. This resilience is key to survival. During launch, the rocket experiences maximum dynamic pressure. The welds must hold against forces that would tear other ships apart. From the top of the launch tower, the factory looks like a giant puzzle of steel rings waiting to be assembled. Specialized transporters move these massive sections with surgical precision, inching them towards the high bay for final vertical stacking. Inside the high bay, the scale becomes apparent. Workers look like ants as they guide the massive cylinders into place. Once aligned, the welding begins again, fusing the sections into a single, continuous monolith of stainless steel and ambition. It is not just a hollow tube. Vertical stringers run along the inside, adding stiffness to the thin steel skin. Relative to its size, the skin of the rocket is incredibly thin. Pressure from the fuel helps keep it rigid. Like a soda can, it is strong when pressurized. This design saves weight, allowing for more payload to be carried. Complex plumbing runs through the interior. Massive pipes deliver fuel from the upper tanks down to the hungry engines. The flow rate is staggering. Enough fuel to empty an Olympic swimming pool in seconds rushes through these steel veins. At the bottom of the stack sit the Raptor engines. They are the most advanced combustion engines ever mass-produced. They can swivel to steer the rocket, balancing the immense tower of steel on a pillar of controlled fire. Installing these engines is a complex dance. Dozens of connections for fuel, power, and data must be perfectly attached. Heat shielding protects the delicate machinery from the inferno created by neighboring engines during the violent liftoff sequence. This contrast between nature and machine defines Starbase. Wildlife roams freely just meters away from the most advanced technology. The environment here is harsh. Salt spray, humidity, and high winds test the durability of the stainless steel daily. But the steel holds up. It does not need paint. It does not need delicate care. It is built to endure. The culture here is hands-on. Engineers do not just sit in offices. They are out here, touching the hardware. Decisions are made in minutes, not months. If a part needs changing, they cut it out and weld a new one. This agility is impossible in traditional aerospace. But here, scrapping $1 million part is cheaper than a failed launch. The scrap pile is a monument to learning. Every twisted piece of metal there taught the team something vital. Beyond the factory, the mission requires orbital refueling. Starship must meet another tanker in space to fill up. This capability unlocks the solar system. It allows a fully loaded ship to leave Earth's orbit and head for Mars. The journey to Mars takes 6 months. The ship must protect the crew from radiation and the vacuum of space. Inside the habitable volume, life support systems will keep humans alive. The steel hull provides the first layer of defense. The shiny steel also helps with thermal control, reflecting solar radiation to keep the propellant and passengers cool. Landing on Mars is the ultimate test. The ship must enter the thin atmosphere and slow down without a runway. Once landed, the ship becomes a base. It serves as a home, a power station, and a shelter. To return home, they must make fuel on Mars. Methane can be synthesized from Martian water ice and carbon dioxide. This completes the cycle. A fully reusable transportation system that can travel back and forth between the two planets. But that future feels far away. Right now, the reality is grinding noise, welding sparks, and long days in Texas. The people building this are the unsung heroes. They are turning science fiction into stainless steel reality, shift by shift. They have also built Mechazilla, a launch tower with robotic arms designed to catch the returning booster in midair. Catching a rocket is insane. But if it works, it eliminates landing legs and allows for immediate relaunch capability. The engineering required for the tower is just as complex as the rocket itself. It is a fully integrated machine. Starbase is growing. What started as a dirt lot is now becoming the most advanced spaceport on planet Earth. It inspires people. Families drive for hours just to stand by the road and look at these monuments of engineering. For a new generation, this is their Apollo moment. They are watching history being written in real time, live streamed. We have not seen progress like this since the moon landings. But this time, the goal is to stay permanently. Nature and technology coexist here in a strange harmony. The future of life on Earth and beyond are connected. As the sun sets over Texas, the sky turns red, reminding us of the destination that awaits us millions of miles away. The floodlights turn on. The work does not stop. The race to become multi-planetary does not pause for the night. Thousands of people dedicate their lives to this project. They are the welding torchbearers of human exploration and destiny. Imagine a future where fleets of these ships leave Earth every orbit window. A bridge to the stars built of steel. By moving heavy industry off Earth and expanding life, we protect the only home we have ever known. It is a grand vision, but it relies on the smallest details. The integrity of a single weld matters immensely. The symphony of Starbase is loud and raw. It is the sound of humanity pushing against its own limitations. From this remote corner of Texas, we are witnessing the birth of a new era. The age of Starship is here. It is risky. It is dangerous. There will be more explosions. But the path to the stars is never easy. We have seen success before. We know it is possible. It is just a matter of scaling it up now. The factory is expanding. More high bays, more robots, more steel. The machine that builds the machine is growing. As long as the steel keeps arriving, the dream keeps growing. Each roll contains the potential for a new journey. The sun rises again over Boca Chica. A new day of welding, testing, and building begins for the Starbase team. The silver towers shine in the morning light, standing as sentinels of our future, waiting for the countdown to begin. We are closer than ever to seeing this massive vehicle leave the atmosphere and carry humans to new worlds. When it flies, it carries the hopes of all humanity. It carries the spirit of exploration that defines us. It is a testament to what we can achieve when we are willing to fail, learn, and try again relentlessly. Leaving the cradle of Earth is the next logical step. And it is happening right now, in our lifetime. SpaceX has bet everything on this, on steel, on scale, and on the belief that humanity belongs among the stars. But for now, the story remains here. In the mud, the wind, and the welding arcs of South Texas. From these stainless steel welds under the Texas sky, we launch our future. Thank you for watching Dark Sky Dive today.